breakfast this morning just because I knew you were going to put grades in.
That's exactly why you should have done it. Yeah.
I bribe him now.
So I always say, when people say, hey, can you be bribed? And I always just say, well, it's definitely not going to hurt your grade. It won't help it either, because I'm not swayed by stuff like that. So it's not going to hurt it. It's just not going to change it at all.
Well, I just need to turn some things in. It scared me a little bit, though.
So that's what it is. And so some of the guys out in the shop have said, well, I've got these projects done. I'm like,
I just opened my drawer and they're all just sitting.
yeah, I'm like, that's the problem. If you haven't turned it into me, I can't give you the grade for it unless it's turned into me. And they're like, yep, you're right. We'll get it done. So good to go. Everybody's going to be fine. Everything's going to be perfect.
The two projects we're working on, we just haven't done milling and.
Yeah. So while we're here, I'll go ahead and jump back into Canvas and we can take a kind of a look at what's going on. I did a little bit of updating this morning because I came in this morning and my plan was to run some stuff for Sedalia Showcase that's happening Wednesday, and I was surprised about the fact that we had no power in the shop.
I need a spare key for my box, number 330.
Give me a way.
Seriously?
Yeah.
Is it in your box somewhere, grab it?
It is in a box somewhere. Yeah. When I come out there, I'll do it. You need to be responsible for your things.
Well, yeah. Well, I'm coming to you.
That's irresponsibility of your things.
What?
And to be responsible for your things would be to bring it yourself. To be irresponsible would come to somebody else, and then
All right,
yeah.
I just go home and grab it.
Well, I can get it. It's fine. All right.
My keys, keychain, so if I don't have my car keys, I don't have my except for the day I lost my car keys. That was rough. I lost my car keys at campus. I left it in Cole's car, and he went back to his apartment. And I was like, yeah, I don't have any keys. Go nowhere.
One of the things that we felt like right away was if we kept a key for everybody's stuff, everybody would go, I'm not worried about it, you got a key. And then we become that key hander-outers every day. And then when you don't return that second key to us, you're like, I don't know. And then that's why we're like, I don't want to be the key. I'm not the key person. So we really want to push the responsibility of doing these things.
Probably ought to make it buy our own tools.
We used to. So you used to buy, when you started the program, you bought like a $500 kit for 101 and 102. And then you bought a $250 upgrade for 103 and 104. That went in that box. The problem that we had was, I think it's a good way to do things, but the problems that we had were that students, one, were having a hard time paying all these other bills, or they were going to shops that already had tools provided for them, and then they're like, hey, well, you don't need any of these tools. And I would have students come back and go, hey, man, I just got this job at Honeywell, and now I have this $750 worth of tools, and I can't use them. So sometimes we would just have those students sell them back to other students at a discount. You know, they had all the stuff in there, and they were ready to go, so they'd sell the whole thing back to them for $500, you know, and that went okay, but, you know, it just became easier for us to maintain those things for you, and as long as everybody has their key, does their thing, then we have no problem. So, all right, so here we are. We are almost at the end. This is week 6 or module 6. We have a thread info quiz. We're going to do just thread information today. We're going to do machinery handbook and micrometer stuff today. And then we'll look at the measurement materials and safety study guide. Then you'll take your test, and I think that I told you.
Another mic quiz. I just took one.
Yeah, but it's our primary measuring tool.
Yeah, I know.
You know what I mean?
I hate it too.
Yeah. You hate it because you avoid it.
Not on the laptop. Like whenever it's on.
Yeah, it's sometimes kind of hard to read. You're right.
I still barely passed it. I sat there for 2 hours, and it was still like
What I do sometimes, and you're welcome to do this, especially if you're here, is when you're taking a micrometer quiz, just go get one. And then that way you can set it to the thing, because sometimes it's like, it shows the arrow and it's like tilted, and you're like, judging by whatever, like I feel like it's not quite straight on, and then you can get a better view of it, and you could be like, okay, so this is definitely what they're saying. So feel free to grab a micrometer, use it to make sure that you're set up and ready to go. All right, so this module 6, then next week is just all shop, all week. Then the final week, all projects are due October 13th by 12 p.m. noon. So that's a Thursday, and it'll be the same week, I believe, that you take, I can't remember what day I told you that your NIMS quiz would, 12th, okay. So, whatever day that is, and I'll put that out as a,
6 right here, right?
yeah.
We got next week and the week after.
Yeah, because the last week has a kind of an odd count to it, but everything must be completed, because technically you get 8 weeks in a final week. And so we don't really do a final, but we do, we basically set it up so that you're gonna do, well, I shouldn't say 8 weeks in a final week, but you have 8 weeks and then a couple days for a final. So we just continue on class throughout that time. The not our final, but our certification test happens just within that time. So we just try to maximize as much time as we can, so there.
And the NIMS, this first test, what certification is that?
Measurement, materials, and safety. It's gonna be this one right here. So it doesn't require a part to it. And do you already have it done?
Maybe.
Okay. So if you already have it done, we'll finagle around some other things. And so we've had some other people who were in that spot. So if you've already got one, then we'll have you do a different one or something like that. So, but anyways, we'll be looking at all of those things today. So let's go ahead and just get started with the machinery handbook. Okay, so find the threading section in your machinery handbook. And my suspicion is it is.
The reds.
Yeah.
These are fun. I went to a family function this weekend. I was telling them about my machining. And they thought it was super cool. But I definitely did not explain it the right way.
I'm getting tired of people asking me what I do. It's hard to explain.
They're like, do you work on cars? I'm like, I mean, I can build an engine, I guess. Make it.
Everything your car has.
Yeah, I can make a car.
I just always answer yes to whatever they say. They're like, is it this? I'm like, yep.
Sure is.
Fine. Page is it? What page is it on?
1855.
1855.
But for some reason, the computer version is not on 1855.
Oh, man.
That's completely different what the computer says.
So if you look through the book itself, I mean, you can see
This is just the tiniest.
it's got every single thing that you could possibly look for in thread information. So at the 1854, 1855 pages, you have screw thread systems. Then you have the unified screw thread systems. You have calculating thread dimensions. Then you have the metric thread system. Acme threads are a standard thread or an imperial thread, and then they're just a little more square thread. Buttress thread is a different shape of thread. Whitworth thread is a 55-degree thread. Pipe threads are sometimes tapered, not always. and then you have other threads, and sometimes what we would just call bastard threads, that would be oddball-sized threads, or just something very unique. Then you go to 56, you have measuring screw threads. There's several different ways of measuring screw threads. Tapping, thread grinding, thread rolling, thread milling. Several ways to make a thread itself. So much so that you get all the way to 2100 and some change of thread. So there's like a half an inch of just thread information, okay? So when we're looking at a thread, so no one's saying you need to be able to memorize every single thing in here. But what we're saying is you need to be able to locate information. I mean, that's how anything is. No one thinks that you're going to memorize how to do everything.
Book is like,
It can be a little daunting. I mean, there's a lot of information there. But so like in my machinery handbook, like you can tell where I spend my time because the pages are really dirty there. Like I turned a lot of threads, so I spent a lot of time in the threading section. If you do a lot of bearing work, or a lot of like press fit type work, you're going to spend a lot of time in there. So I don't think there's anybody who like knows the pages cover to cover. But I think that everybody knows kind of the sections that they work in the best. And so today, because if you can get the concepts of threading and how to read the charts and stuff, it's just really going to make the other parts of it flow together pretty good. So let's just take a standard half 13 thread. Okay, so really simple thread, half 13 UNC 2A. Okay, so I want to blur a couple of different pieces of information together as far as threading information, machinery handbook stuff, and then NIMS things. So all of that stuff, whoop, stand by. Here we go. Get back over here to the camera. All right, so half 13, UNC 2A. Now, judging from this thread, you've been cutting this thread or you have cut this thread. This tells us that it is external. It's an outside thread. Okay. Somebody go get their thread or their handle from their camera. This is the class of fit. Actually, I'm going to do this internal, external.
take a picture of this.
Wait till I get done. Yeah, just remind me before. And it's recording, so you can always go back to it too.
Okay.
This is unified.
So could somebody theoretically go to your YouTube channel and teach themselves machining?
I think they could. The theory
Basics?
part of it. Yeah.
Basics of it?
Yeah, so we had the scouts in this weekend, thank you. And we didn't do machining with them, but we did robots and automation with them. And we did that all day Saturday. And it was really cool. They were the first students to get to use our universal robots. Literally, we just, like anytime I was not here last week, I was running over there, putting those things together, and me and another guy were working to get it ready for Saturday. And so we had a great group of about a dozen kids who came in and learned how to move these robots, how to program them, how to manipulate them. But so I had a couple of tours come over through here, and they were like, every once in a while I like to know how things are made. And so every once in a while I'll hit YouTube to try and figure out, like I need an engine bored out, how does boring happen on it? And so I was like, well, yeah, we record all of our stuff and have it on a YouTube channel. And they were like, so I could just subscribe to a YouTube channel, or is it just for students? I was like, that's open to anybody. I mean, there's tens and tens of people who watch it, so you could.
Tens of
yeah. So there's, you know, it was like totally out there for you if you want to watch it. I was like, we're not trying to curate amazing YouTube content. It is literally just us in class. I think you could definitely gain a lot of information. It's not going to teach you to be a machinist, one, because you never run a machine, you know. But it would definitely give you a leg up before you came in. So, like, we won't go back and reference these videos next semester. These videos just go into the archives, and new videos come up next semester, and we just keep on going as we go. So.
Yeah, my uncle bought a lathe, and he doesn't know how to run it.
So,
Yeah.
So, like, right now, we've got already put out there how to run, like, the CNC lathes. I've got a video of me running it from start to finish. This is how you power it up. This is how you home it out. This is how you check the fluids. This is the axis X. This is the axis Z. Here's how you install a tool. Here's how you touch a tool off. So everything that you need to do, by the time you're done watching those 23 videos, you can load a program into the machine that somebody else has created, touch it off, and do it. I mean, literally, anybody could do it. I mean, that's how we teach our students how to do it. And so we're working on videos. So like your uncle who bought the lathe, manual lathe, we'll have a video. Matt Parker is our person who's working on those videos. Here's how you turn the lathe on. Here's how you check the oil in the lathe. Here's how you calculate the RPM for.
That'd be the hardest part of running a manual lathe.
Yeah. But the thing about the manual lathe is you only get certain options. So like I've got you spinning at 960. It's really not where I would want you, but that's the closest zone that I can get you to. So, and you know, you get the ability to go whatever speed you want there as long as the machine can do it. Where you could go 2,057 RPM, or you could go 2,500, or you can go 2,501. You can go whatever you want there. But on the manual lathe, you have to be in those sections. So it's about finding the right surface footage for the piece of material that you're working on that fits in the closest gear selection that you can go to. But yeah, I mean, honestly, a person should be able to follow our steps and run their own machine and really never come here. And honestly, I don't really care. If
Yours for the paper to, go get a job with.
Absolutely.
That's what this is, to get a degree. And you're learning a lot more than you
That's
want.
just it.
You are.
Just like we're videoing this, it really pertains to us right now. And if you were watching it, you would skip through a lot of this stuff. And then, because it really is, it's made for us. It's not really made for presentation to the world, This is a reference.
Come into class, not know what they have to do, get out there and do it.
Yeah, this is for you to go back and go, what did he say? It was Unified National Course? Fine. What did he say? So that's those that's all that these videos are for. So this is Unified National Course. This is what we call TPI, or threads per inch. And this would be the nominal size. Okay? So on this thread, all of your imperial or standard US threads are like this, okay? So it's a half 20, it's a 3/4 10, whatever it might happen to be, okay? So once I see this on my print, if I'm not using a die or an automatic OD threading tool like we had, I've got to do single pointing or something in order to get this external thread, okay? So I know it's an external thread because it's A. So that means if we tapped the hole, like you guys have already done some tapping, that's a B, okay? So it's either A or B. So external threads are A, internal threads are B. Class of fit, we're going to look at in just a moment. Unified National Course, Unified National Fine, Unified National Extra Fine. Those are kind of our classifications of fit right now. And then this could be, actually there's a half 12, there's a half 13, and there's a half 20, probably half 28. Those are kind of your thread selections. You want standardized threads because you don't want, between the 5 of us in here, all of us making half whatever thread we want, right? So Steven's making half 28s, and I'm making nuts that are half 14s. And we go to put them together, and I'm like, dude, you you didn't put enough threads on your, or you got too many threads on your thing, and he's going, you got not enough threads on there. Yeah, just bear down on it. We want to, that's why we have this.
Reach out, let's diagram.
Yeah. Standardization. Well, so that's what they used to do, is that early machinists, they would make the bolt and the nut, no big deal. Everything went together fine, until you needed a new bolt or nut. So we built this standardization. We didn't. Somebody built standardization into it, which makes life so much easier. So when doing that,
Does it though?
it totally does. Yeah, so that means that, well, think about it like this. If you are driving down the road and you have, well, you were telling me about some lug nut problems that you had one day. Imagine if you strip off a lug nut, and let's say you strip off 4 of the 5 lug nuts. You're not getting home like that. You can get home without 1 lug nut. That's no big deal. But you're gonna need to go to O'Reilly's or something and go get some more lug nuts, right? And you don't want to have to go, hey, I need 4 lug nuts, and they go, what size? And you're like, standard lug nuts. And they're like, I'm gonna need your lug nut stud and your lug nut to make new ones.
Yeah, that would suck.
You want to just pull them off the shelf and go.
Right.
That's why standardization is so good for us. Yeah. We need some uniformity as we go throughout things. That way I can walk in, grab the thing, go put it on there and know it's going to work, you know. I mean, there are some variations, you know, between automotive manufacturers, but they're all within a window, you know, and they're mass produced. Exactly, yeah. So you've got different manufacturers that have different things.
When they ask you two-wheel drive or four-wheel drive, I need to know that about whenever I buy windshield wipers.
Yeah, so I saw a car, and I saw this meme that this car was on fire, and they were like, this is why you specify if it has LED lights or no LEDs. This is why you specify if it's automatic transmission or whatever. Like those questions that they ask you that are just outrageous, you know, you're like, I don't know. I need a valve stem cap, dude, you know. It's like, that's what.
I need a gas cap because I left it on my car.
Right,
I need to know why.
Yeah. Is that turbo? I don't know if that matters, you know. Is it blue? Is the car blue? What's the color? Yeah. How much air pressure do you currently have in your tires now? I'm not sure why you're asking me these questions.
Check it, you can.
I saw something the other day. It said, the guy who works for me came back and said he couldn't get the tires to 100%. And so it showed a picture of the dashboard with the tire inflation, you know, on it. And they were like at 97, 98
Oh my.
pounds, right? So these things were like ready to bust, man. I was like, oh, I could see that though. Somebody thinking that you're trying to get to 100%. So, you know, it has to do with, you know, kind of expectations. And so there's a lot of assumptions. And so the more that you know here, the more those assumptions.
Now, 4 people to go by that are stupid.
Oh yeah, I know. Yeah.
If they make like fake stuff at O'Reilly's, it's in the back. You can find it. It's called
Yeah. I think that's funny. Somebody's buying it.
Somebody's bought it before, that's why they make it.
Okay, so here's what I want you to do. Get to your pages around the 1880s section. Yeah, 1880, and I want you to try to find the half 13 thread. Might be a little before that. I'm actually in about the 1870s now.
Dang, man.
A lot of information on there. I'll give you a tip that will make life really good for you, is if you will take your scale can be used for all kinds of things. It is like Swiss Army. And if you will lay it on, let me get to the page on the book.
I found a half 16.
Oh, okay. Yeah, that's not the one.
Are we trying to find half 13?
Half 13.
Half 10, half 12. and
I
then
found a half
plus
13. UNC 2A 1A. It's UNC 1A. I think. Yeah, I found it. It's on page 1873.
So this section here contains threads, kind of all of our real common threads, big or small, whatever it might happen to be. And
I'm not finding it that quick.
what?
There it is.
The computer's hard to find it.
1873.
It's either?
On the, in the book.
Yeah, just use the book.
You'll have the book, don't forget it. I know.
The book's, definitely, oh, I can't bring this. Can you buy these online, or the same one?
Same thing, man.
You could use this book in there.
Well, I mean, home, how much do you think they cost?
About $100.
Dang. No, I don't think I need one. Damn. Why? It's just paper.
That is true. It is just paper.
A lot of it, though.
A lot of
I
writing.
really want to go get I just really want to go get a caliper
Go
and see
there.
how thin this piece of paper is. That's what I really want to do.
You can do that. You can go do whatever you want. Okay, so on this, it's 1821, 27, somewhere right around there. So in the book, it's 1872. You can have this book with you when you go to your NIMS test, okay? You can have a calculator, so a machinery calculator. You can have this book, you can have a piece of paper and a pen or pencil, okay? So I used to just say you can have a piece of paper, one of these and a calculator, and somebody was like, can we have a pen? And I was like, yeah, you could have a pen. And then a person, can we have a pencil? I was like, okay. Felt like some of that was assumed. So yes, exactly, this is what you can have. Now, here's what I'll tell you about, you can't go in there with any.
Take our machine calculator.
You can take the machine, yeah, but you can't take a phone calculator though.
Because I don't have, I need a, how much is it just to buy, like, one of those, like a machine calculator?
$100.
That's not
About
bad for a
$100?
calculator, though.
What?
Is everything in our toolbox about $100?
No.
Calipers are like $60.
The digital ones are about 200, I think, is what those are. So.
The dial.
The dials are longer, so I'm not sure what those are anymore. I should. I'm right in the middle of buying some new boxes. Okay, so half 13 UNC. Now you can see class of fit. So look how all these are external. See how the category is external, and then internal. And if you look over here, you've got B for external. You've got A, or I'm sorry, you got A for external. You got B for internal. Now you have your major diameter. Your major diameter is the outside part of this thread. This is the part that you could measure with your calipers or your micrometer. I told you specifically when you turned this diameter, not 500, right? 500 would be a ½ inch. So take a look for our half 13 2A, 498 to 487. That's the tolerance for the outside of it, right? So if you went 500, you would have automatically been too high, right?
Wow, that's like, ooh.
So about 490 to 495 is about the nominal for that section. I generally say 495, assuming that you'll kind of go somewhere right around there. When you create a thread, it's okay that it's a little small. So for an external thread kind of looks like this. Okay, it's got the external part of it. It's got, this is the major diameter. This is the minor diameter. Both of those parts should not touch the female part of it or the internal part of it. So when you tap your hole, there should be a gap here. There should be a gap here. So these parts of it should not actually engage into the nut. So like on your flange nuts, if you were to dicom that up and screw it on, it should scrape off some of the dicom, but it shouldn't hit it off the top, very top and the very bottom. And so you kind of build yourself in there a little bit of leeway to work. The areas that you're going to have major contact on is this area right here. And that area right there, so the midpoints of the thread is where you get most engagement. That area is called the pitch diameter.
And that's, my Lord.
But not to be confused with pitch, which is also here.
The length of the.
Yeah, high point to high point, low point to low point, midpoint to midpoint, so 2 even points.
So nuts, they designed threads that way for it to like
Exactly.
not strip as easy, I'm guessing. 'Cause
Well,
it goes lower down into it, not
yeah.
the top.
So the idea is that you can have, everything has built in with some tolerance, right? So if you work in the food industry, the quarter pounder hamburger has some tolerance to it, right? If you,
Quarter pound.
yeah, and even though it's pre-cooked weight, it still has some tolerance to it. A building, construction, everything has some tolerance to it, right? Your coffee that you're drinking today, they say approximately 2 ounces of this, approximately 4 ounces of this, approximately half a cup of ice. There's tolerance built into it, right? So that's why you can have 2 of whatever that is. You can have 1 every day for a week, and you can be like, this isn't exactly what I had yesterday, but it's pretty darn close, right? It doesn't taste like.
Our tolerances are a lot closer.
Our tolerances are closer than the frap. Yeah, absolutely. So, but everything in life has a tolerance to it, right? So, and so having it engage on the pitch is where all the engagement really is most important. So kind of 80% of that thread in the middle section of that angle is what you're concerned about.
You got the tolerance of the college girl.
What's that?
What?
Yeah.
So you got the
Yes, yeah.
There's one, 1861 shows a good picture of that.
Right, yeah, there are
1861.
1861 in the electronic one. Yep.
Man, this stuff is interesting, I'll tell you that. I never thought I'd go this far into just a screw or a bolt or whatever.
Right? I walk into Orchard or something trying to find me a screw bolt, but I never thought about making my own.
Usually I'm just like, oh, that one looks like it'll work. And just grab it off the shelf and take it.
So we'll look at some of those things here in a minute about why you don't.
But 1861 shows a good what the tolerance is and stuff.
Yeah, my grill's held in by 2 random nuts and bolts I found at the co-op.
Well, and you know, and that happens sometimes too. I'm not saying that necessarily those things are, like, you don't have to go crazy and.
I mean, if you're building something for somebody else or like for a factory, you need to go like exact on. It needs to be perfection, right? Because you're giving it to somebody else. You're selling this product.
Exactly. And you want that person, if you're shipping it across the country, for them to be able to find replacement nuts and bolts, fasteners, and hardware so that they can make that thing work. Yeah. And so, yeah, here's your rough idea of what your thread looks like. And honestly, in most of these things, what you're looking for is major diameter, minor diameter, pitch diameter, and then kind of just the feel of the fit. Okay, so all of those things kind of play into it. But like when you're creating the thread, typically you're not paying attention to every single one of these pieces. But you can see, so when I created my thread here, and then I have my other thread here, there's a gap between those, right? So, and obviously those are small areas, sometimes just a couple thousandths. Okay, so we've got our 1/2-13 thread here. It holds quite a bit of weight, right? It's a pretty strong bolt. So if I need a bolt that's stronger or can hold more weight-wise, shear strength-wise, not shear, but it can hold more weight on it, do I want more threads or less threads?
More.
Okay, but when I make more threads, my threads get shorter, don't they?
Bigger, long, like bulkier threads. Less thread.
How about less threads, deeper threads?
Yeah, less but deeper threads. Yeah.
Okay, you say more threads, shorter threads? Okay. More threads equals more engagement equals more holding ability. Okay. So typically when we start to go down in thread pitch or coarser in the thread, it's because we have less gripping onto it, but we want to thread it on faster. Your strawberry milk or whatever you have there, is that what that is? Yeah. Are you 7? Okay. Okay. Yeah. My oldest son now, who's 25, used to love strawberry milk. I mean, he was just like,
Strawberry milk is
yeah. I don't like milk. Yeah.
what? Oh my.
So lots of times on a thread like that, like imagine if you had to do like 9 threads to get that cap off. Oh, you'd give up, right? Oh my gosh. So.
Just drink it with the lid on.
Right, you know, you might, yeah, you would just take the lid off, throw it away, or you just be like, I give up, you know, whatever, I'm going back to TikTok. And so what would happen is you see that doesn't have enough value, you start buying a different kind of milk. So that's why there's like one thread around that thing, right? So like they've determined that you have enough energy that you will expend to take one thread off there. And sometimes they'll be double lead or double start threads, so they'll actually go twice as fast on there. So, so you can, by increasing the pitch like that in double lead, triple lead.
I never thought about threads that way. I've never thought about soda bottles and stuff like that.
Soda bottles are a great way to see
It's
what.
like a nut in a bowl.
It's a nut in a bowl, yeah. Soda bottles are a great way to see double, triple start threads. So like if you ever put a nut.
Push it backwards, it falls into place, and you start it up.
Yeah, like you can, well, you'll get thread engagement by going halfway around rather than doing a full turnaround. Like a normal, this one is gonna require you to take the nut and no more than one full thread around it is gonna have engagement, right? Now, if you have a double lead thread, no more than halfway around it, it would have engagement where it would start to stick on there. Triple, then you would go a third of the way around it. 4 leads, a quarter of the way around it would have engagement. And then it would feed on there so much faster, it would just start to accelerate the more starts that you have on there. But you get less strength. So if you got pulling on something.
The finer the thread, the better.
Finer the thread, the more holding power that you get, okay? There used to be a commercial where they hung a truck from a bolt, and they were like, look how strong our bolts are. And I'm like, right, you didn't make those bolts, but you bought those bolts and put them on your truck, and anybody can do that. And yes, you do have insane holding power, but a bolt has no power shear-wise. So if you were to hang that ram truck from the bolt, and you took a sledgehammer and hit it across there, it would just shear off and the truck would fall. Because when you make these things, you're making shear points, right? So a lot of times in our threads, we'll put little valleys down in there.
That's what I was looking at on the one that's on the screen right now.
Yep. So a normal 60-degree thread has some valley in the bottom of it to help build some strength back. But that's not the purpose of the bolt. The purpose of the bolt is not to have insane shear pressure. It's to fasten two things together, right? And so then they essentially, the nut or the hammerhead or whatever, it goes down over it. Shear no longer becomes an issue.
So how do they build bolts that are meant to take severe like vibration and stuff like that?
They're,
Fine thread.
Calipers and stuff like that.
once they're connected to the other pieces, then it's like they become solid. Right, because let's use brake calipers. So you've got those socketed cap screws that you screw in there. The head takes all the weight, or it takes all the pressure, right? And so it actually never gets to the point where it's hitting against the thread, or this large area is what pushes against the thread. Never is a chisel coming through there and smacking it to do that, right? So yeah, if I took a chisel to this and checked everybody's threads, I could knock that thing off there. But also, that's not the point of it. You know, it's to fasten things together. So you got to know what it is that you're doing. But you do need to know that if there is something sticking out like this, it becomes the weak point, right? Like, so I don't know if you're like me. If you let's go back to your lug nut story. If I'm out and I've got 4 lug nuts off, and I'm trying to get the last one off, and I'm like, man, I'm just going to sledgehammer this thing off. I'm going to hit every freaking lug nut and break it off on accident because I know me. And I will miss every time I'm trying to hit it. And I will be like, why'd those things break? Well, because somebody created all these V break points in there. And now I'm going to be like, now I got 4 broken off lug studs. I've got this one stuck. Give me some hot glue. I think I can make it home. You know, Loctite, zip ties, whatever.
It'll ride. It'll ride.
We'll go. We can go. So, all right.
Dangerous.
So let's go back to, you're at 1872. I'm going to go back to whatever page.
Why don't we go back to 1776?
We could, I don't know that any of us would really want that.
What? Isn't that when America was founded? 1776? I think so.
Declaration of Independence times. Okay. Okay, so here's our thread chart back again. So we have our half 13, our major diameter is 498 to 482 for a 1A. It is 498.5 to 487.6 for a 2A. And then 500 to 489 for a class 3. Which one's got the most amount of tolerance to it? 1, 2, or 3? And then which one has the least amount of tolerance to it? So, quick way to figure it out, just do the math. Take these two numbers, subtract from each other. What's the difference? Do it for all three of them, 1, 2, and 3. Tell me which one has the most tolerance. I'm just gonna write it here. 1, 2, and 3 for class of fit.
Dang wind blew my pages around. I'm on a whole different page now. Moving over from that.
And I went to Casey's for the specific purpose of getting cash back so I could go to a stupid volleyball game today. Get in there and go pay for my stuff, and I'm like, no cash back. Hate you all.
You had it that way for a while, didn't it?
I think that's how they all are. What?
Yeah, I think everything around Sedalia is just not doing cash back.
Dude, either. Yeah. Okay, what's class of fit, or what's the tolerance for, did you have?
I figured out by just looking at it. 3 is the highest for sure.
3 has the most tolerance,
I'm thinking.
or the least amount of tolerance? By how much? Do some math, do the hard work. I'm gonna go grab a couple thread gauges.
109.
Stand by. 109 sounds like a lot.
I'm right on that though, right? 3A and 1A.
3A, right?
3A, 1A, 2A.
94. Am I even looking at the right stuff, man?
What do you think, Steven?
Because the first one has
I'm
that.
just looking at the classes and moving down to 3 and then.
Yeah.
One 14 is half 12, 3A, class 3A.
Okay, 1, 2, and 3. Got the numbers?
I got 3. 3 is 114.
It is 0.114. Tolerance?
0.114 is a 0.014.
That sounds like a lot.
Hold on.
I feel like you did not do the math.
I typed it into the calculator, probably not right, but I definitely did. All right. Okay, here it is.
One has 0.0163.
0.016.
I actually got 0.0109.
16,000.
0.03.
Which one? I think that's the same for 2 as well.
So tell me again on 3.
0.0109.
0.109.
Yeah.
0.0109.
0.0109.
And did you say 2 is the same way?
Yep.
Really?
Let me check.
Exact same?
I'm getting it.
It can't be the same. Well, I mean, I guess it could be the same.
It's about the yeah.
It's the same.
It's the same.
Same? All right.
I mean, I really would.
So who has the most tolerance?
2 and 3. No, the most tolerance is 1.
The 1 gets 16 thousandths worth of tolerance, right? So you can have variation. So like, if you go buy a hardware store nut and bolt, put them on and you're like clank, 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 it fits, but it doesn't fit like smoothly running across it. That's your variation, right? I mean, it works, it functions fine, but it's not as smooth and tight as these are. So now then, 3, it has the same amount of tolerance as 2, but it goes up to a higher dimension on the outside. It goes all the way to 500, right?
Drugs.
So, yeah, I think all of us think that right now.
Right.
Yeah.
Got a whole thing of, oxycodone.
Yeah, okay, yeah. It looks like it.
It does, actually. They're mints. I got it from a Golden Valley Memorial Healthcare. Yeah, they're gonna give me some drugs, probably.
Yeah, if anybody's gonna have it, it's gonna be them.
Right.
Yeah, so were you in Clinton?
That's from the job fair. I just remembered I had it.
Oh, yeah. Remember that?
Bunch of mints.
Yep, they're like this.
I got this from the job fair. It's a
Yeah, I
fractional
got one of
straw.
those straws, too.
He's like, yep, every college student needs a straw. Why do every college student need a straw?
So they can drink a drink.
Drink drinks or snort something.
Or drink drinks.
Yeah.
I was just wondering why he said there was, I was there when he said it.
Yeah, I was like, what are you trying to imply here?
I would be like,
They gave that to us was it Nucor? Nucor, yeah.
Nucor gave it to us.
yeah, it's odd. Okay, so as far as our tightest tolerance, so if I said, what's a tighter tolerance, a class 1 or a class 3 thread?
Class 1.
Tighter towards.
Oh,
3.
3.
So it goes from loosest to tightest, right? So at least like you got
Which women came with a manual like this?
What?
Which women came with a manual like this? We're not gonna go there?
I'm not. I am happily married.
Which one has the best tolerance?
So, okay, so 2 is kind of your midway, so that's what we have here. We have external and we have 2 for class of fit. So
Gosh, just those.
all we've done is just those tail end 2. But now some of the other ones though are pretty obvious, right? So threads per inch and nominal size and stuff. So
I bet if I showed that, like, it looks like an equation, I think my mom would try solving it, like math.
I would put it in front of her and be like, hey, can you help me out with this? I'll be right back. And then just don't come back. And she'd be like, I'm not sure what this is. You know, be like, this is what we do all day. Surely you can figure it out. All right, so if you look down through there of your half 13, it shows Unified National Coarse, Unified National Fine, Unified National Extra Fine. And so you get several choices as you go down through there. Now across there, it also gives you your, so we've done major diameter, so we know that we're not going all the way to 500 most of the time. Your pitch diameter is the halfway point between the threads. It's measured with this. So I know that you guys like the micrometer a lot. And so this micrometer is slightly different than a normal micrometer. And I have the hover cam, but I think we can just put that. You do not have micrometers like this in your toolbox. So if you'll look, I'll bring it over to you. See how
Why is it pointed?
it's a red micrometer.
Red micrometer.
Right, you've seen them before, right? Yeah. So here's the thread micrometer. So it's got thread built in. So it's only meant for checking threads. And so you just set the thread in like that. And what this is measuring is the pitch, okay? So it's not measuring the major diameter. You can use a regular micrometer for the measuring of the outside diameter.
But you gotta use one of those to measure the pitch because you can't get.
Exactly. You can't get that micrometer down. You definitely cannot get a pair of calipers down, even though you'll try. You'll be like, oh, I'm pretty sure I can get it down there. I'm like, you cannot do that. I mean, it just doesn't. It's just not meant to do that.
Unless you got some big old threads on that thing.
Oh, yeah, I guess that's true. If you had some really big, giant threads, you could probably do that. Okay.
Big old threads.
So I'm measuring this one, and yeah, appreciate that.
Hit the rewind on the recording real quick.
Right.
We need to re-record that part.
Yeah. Yeah, we're gonna erase
What? Dang. Like the, what's that Bugs Bunny meme? Oh my. Oh yeah, the Meat Canyon one. That is hilarious. It stinks.
Am I wrong? Am I wrong, or is what are we looking at?
Well, it is a little bit off, but,
It'll ride. You could put a nut on there, I'm sure.
Well, the note fits perfectly.
Oh, I haven't even tried putting mine on yet. I don't even have the holes drilled through my hammer.
you shouldn't. Remember, we're doing all the lathe work. And then we're gonna go down and do.
Okay, so that's why I have projects that are just sitting there.
Yeah, so that project's
That's
gonna
why we're
sit there.
90 or 40% in the class, because those two are zeros right now.
Yeah.
Yeah, that's why you're at zeros right now. I'm not sure why this is off.
I know they have that aluminum
Who's
block.
the one that made that thread on that one?
You know what I'm talking about?
Part of it.
Appreciate your throw you under the bus
Just
mentality there,
Just
man.
saying. That was the test dummy right there, is mine.
I don't know how. It's probably because I've done more classwork than you. I've done like.
I've done all the classwork. I've done all the classwork already.
Oh, okay, so this is measuring the minor diameter, sorry.
Except for this week's, have you done the micrometer quiz?
That's all this class?
Yeah, we're gonna have to do the micrometer quiz.
The micrometer quiz, okay. So here you have your thread micrometer, and then you've got, on this it shows,
Well, you got a thread, what is that? Have in it?
this, it said, actually, oh, that's just part of the instructions in the book.
Oh, it's in.
This tells you, oh yeah, here it is, what it does. 10 threads per inch to 13 threads per inch. So if you have a half 20, you can't use this micrometer for it.
Is there different sizes of thread micrometers?
Yeah, so all of our thread micrometers are 0 to 1 because all of our threads that we check like that are in the 0 to 1 range. So we have, the next one is like, it doesn't go 14 to 20, it goes like, I think it's like 10 or 12 to like 28. So there's ranges of thread micrometers that you're gonna use for each one that you use. Okay, so then you have another type of thread gauge. So thread gauge like this. So this is a go, no-go gauge. So if it goes, it's good. If it no-goes, like it doesn't go on there, then you know it's too big. Okay, so this one, half 13. I've got this is half 13 UNC 2A, okay, for external threads. It goes on there. But the idea is, so it really just checks, does it go on or does it not go on? Definitely doesn't check, is this the right pitch diameter? Okay, so here you're checking diameters, so, and then your regular outside micrometer, you're checking major diameter. But here, you're able to just check, does it work or not, right? This can be super loose and not go on at all, right? Or I mean, and not be a good thread. So just because it goes on here, you want to kind of check for the shake that you get in there, and I'll let you pass, or I'll pass this around so you can try it out. And the thread that we're making here is fine for what we're doing, but it's set and calibrated to a size, and then you'll use that tool for checking those. This is a factory ground thread. It is set for your internal threads, so your B threads, okay? So this one is a half 13 UNC B. So like on your,
Go and one side's no go?
one side's go, one side's no go. Your long side is go and it says go on it, and your short side says no go, and it's probably, yeah. So, let me try to get some of this wax off of here. No, they're it's got a protective wax on its ears. Okay, so, let's just assume that this is a tapped hole. And so I check it with my gauge. My go gauge should go down into it. My no gauge should not even start in it. You can take a look at the threads on it and see The threads on the no side are way, see how they don't even come to a point?
Yeah, no.
So that's how we would check a thread milled hole or a tapped hole, thread formed hole, some type of internal threads. That's how we want to check it, because we can't micrometer check it, right? I mean, you could like telescope engage it, you could gauge pin it, but you don't really have a choice or a chance to check it in another way.
How about, you have those, they're meant for, gauge, screw stuff, yeah. They're like really thin pieces of metal.
Feeler gauge?
Thread wires,
Yeah.
feeler gauge, what?
Yeah, feeler gauge.
Feeler gauges aren't,
I don't know what they're called, I have to ask Ed, we did like a whole thing over them, they were like super thin pieces of metal.
flat pieces,
Yeah, very flat.
so like, but they fold out,
Yeah,
feeler gauges.
doesn't feel, okay.
Yep.
Then they are feeler gauges.
So we also have thread wires that we can use. And the way the thread wires work, they take a little more work to do. We used to use them a lot, but we don't use them that much anymore. So you would it takes 3 wires, and you put these 3 wires, and then you take your micrometer head, you micrometer over those with 3 wires, trying to hold them all in there together. And then there's a constant, a little bit of math formula that you use to figure out where you're at.
I'm good on that.
It does take a little more time, but
Math
it's really simple. It's like the major diameter minus the constant to figure out what the pitch diameter is.
By 345.
No. It's just a quick formula, and what's really good about that is if you don't have the right thread wire or thread gauge, and say you're just making some oddball bastard thread, 14-inch, 20 threads per inch, right? And so you got this big thing. Well, no one's gonna have a gauge for that, so you can set up thread wires to make sure that it's right. Another way you can do it, we'll look at it in a minute, is to take it to the optical comparator, and then you can see some of those things there too. Excuse me. We'll use it here in a minute. Okay.
Is that like more for later on, like CNC and stuff? Is that why we haven't, or is it like?
So now, it's really, the optical comparator happens lots of times and in lots of places. It's just another method of checking things. It's one you'll go to sometimes when it's appropriate, other times when it's not. So if you're doing some radius, actually, let's just go do it real quick. So we'll take this out.
Glasses?
Yeah, go ahead.
Go in the
We're
shop.
gonna be out right here in the shop, right here at this little area. Okay, so that's some of our thread information. And then a couple of different ways.
There's a lot more left.
Oh, gosh, there's just so much stuff, right? There's just so many different things. Okay.
Writing it seems like it was a lot.
What? Oh, so this morning I came in and we had to work Saturday because we had to do a Boy Scout group. And so came in and this morning got here about 6 and I was like, I've got the live tool lathe about half touched off. And I was like, I'm gonna go ahead and get the last of it touched off and at least start running things. No power.
See anything in the shop?
Nothing in the shop. We didn't get power till like 7 o'clock. And I was like, you guys are freaking killing me, man. And, but, you know. Nope, something got tripped over the weekend. So must have been late Saturday night or Sunday. Could have been anything, you know. And, yeah, so I turned it on. That's all I've done today. I've got about half the tools set up on it, but that's about it. I've got a program wrote for it, but
Are you gonna make the wheels on it, or?
that is the goal. That may or may not happen. We've got the Sedalia Showcase on Wednesday. The plan was that we would be running it.
What
But
time is that?
it's like 11 to 1. So.
Till 2 today.
Huh?
I'll help you. I'm here till 2 today.
Yeah, I'll probably need some people to kind of stage up some stuff. We'll have the governor here and some people, but yeah, we want students in here doing some stuff. So, okay, let's talk about. Did you need me? Okay. Let's talk about thread milling. Okay, so we've done tapping. Actually, let's cover tapping just a little bit more before we move on, because I feel like that's still one that we struggle with. Everybody got one of these?
Yeah.
Okay, grab it and put it in your hand. Yep, if you need to go grab it, then go grab it. Actually, while you're there, if you have a handle done, go ahead and grab it. Also, I want you to grab that little thing. It looks like a fold-out comb that has the threads per inch on it. It's that little pitch gauge.
You want decimal for decimal equivalent?
I want, yes, decimal equivalent.
Do you still want me to go grab that stuff? I might as well. The hammer?
Hammer handle.
I got one from my from metrology that he gave us. So,
One of these.
yeah.
Which one do we want, both of them, or just the one?
Decimal equivalent.
Yep.
Nice, I forgot the pitch gauge.
Yeah, don't forget that.
Did you show me how to fly cut?
I can. Give me a few minutes with these guys. Let me finish them up and then I'll be out there. Not quite done. Going through threads and Handbook and Micrometers, but let me get them to a point and then, yes, I will be happy to. Do you already have a flight cutter set up?
Yeah, I set it up from what I've seen.
Okay. Yeah, perfect. And then, yep, I'll come out and help you here in just a minute.
All right, thank you.
Yep.
Which one grab those, actually?
Just the inch. Is this yours? Yep.
said you wanted these two variegated.
The comb thing.
Right. I don't know which one was which, so I grabbed it.
One is what we need.
I don't know which one's metric and which one's.
Well, the one that,
I just grabbed both.
so those are all metric threads.
Okay.
These are all
How much should I write there?
okay, so we've covered that. Let's take a look at your hammer handles. Pull out the pitch gauge to 13 threads per inch. And make sure that those teeth go into there. Huh? It should say 13 on the side of it. Yep, so make sure you have the fractional. That's the metric, I think. Yeah, that one's metric. So here's what students sometimes do, is they cut their threads, and when that pitch gauge goes all the way in, they think that they're there. That isn't necessarily true. That will give you a rough guesstimate of is the thread to depth or not. I mean, it's called a 60-degree sharp V thread because it should get to a point that's sharp, but really that's not the accurate tool to measure that, you know. So what you're measuring with that is, does it have the right pitch? Is it 13 threads per inch? That way you're not taking a scale going, well, I think it's 76 thousandths per
Why
thread.
doesn't everybody just cut their threads to an inch?
You know, I don't know. That's probably what everyone should do.
Right.
Yeah.
Everything should just be bigger. You know, we shouldn't have smaller.
Right. And all shirts should be blue,
Right.
and all cars should be red 4-wheel drive.
F-150s. That way we'd have to pick, you know, there'd be nothing to get anybody else off the road.
Why would I ever drive an F-150?
I wouldn't.
I would not.
Only truck in America?
I would never own a Ford product in my
I
life.
have owned a Ford product, and I tell you what, it didn't run very good.
I've never. I
F-150.
would never do that to myself or anyone I liked. So,
I mean, that thing was throwing
Don't like me too much.
spark plugs.
yeah, it's okay. People make mistakes.
There was throwing spark plug. The thing was throwing spark plugs.
I'm trying to figure this out though. Why did every other car company need a government bailout besides Ford then?
That has more to do with economics.
That
And
has more to do with Ford's a better product, they sell more of them, they don't need help.
so let's just talk in the hot rod world.
Hot rod world? What part do you wanna talk about?
What is the primary style of engine in the hot rod world?
350.
Right. Why?
The reason why is because it's so easy to work on.
Parts are easier to find, but the 350 is reliable.
The 351's a lot better engine.
No way.
Yeah, it is.
No way.
That's not a better engine.
No way. No way.
Big old big 350 learn.
351's gonna have to do that 350 any day. Torque
That is-
wise, with torque.
That is not true.
It is true.
It has a
So don't.
19.
Don't talk to me.
Okay, Ford has a 351, Chevy has a 350.
Chevy square body with a 350 in it, and that thing is.
You're gonna be a 351 big lot.
If it runs and gets me from A to B, that's all I care
Yeah.
about.
Okay, so, all right,
You're
that,
not with them though, you're not a Ford lover.
no, I'm
I
gonna.
drive a Chevy. That thing hasn't broken down for a while, but the battery was the only thing I ever had to work on.
That thing is, those Chevy
Cavaliers.
Cavalier thing, those things run forever.
Yeah.
Dude, I've never seen one break down. I mean, I've seen them driving around with the wheels sideways.
I know.
Demo derby. They go there and demolition derbies all the time.
All right, let's switch real quickly, just for time's sake. Grab your decimal sheet. Let's go to half 13, okay? So you're gonna go over to the chart that says tap size, okay? So on the chart, there's a column that says tap size. You're gonna find half 13 on there. And so here's what I want you to do is you just take your scale and go across with it like this. Okay, so you can read, and I want you to see what the tap drill is next to it. It'll be a fractional size drill that's even to half 13. Okay, so
Size, right?
I went over here to tap size.
There's like 8 different tap sizes.
Right, but they're continuations of columns. So if you'll notice, it goes drill size, decimal, tap size, drill size, decimal, tap size, drill size, decimal, tap size, and they're getting progressively larger.
Okay, and then I need to do half.
Grabs on chart.
There it is.
Okay, so now what's the fractional drill size across from it?
13, 27/64.
27/64.
So half 13.
There.
I'll lose this.
So now there's 27/64. That's right beside it. So 421.9 is the decimal equivalent for 27/64. But 27/64 is the drill that you would use
Before you tapped it.
before you tapped it. So you would spot drill it, center drill it, whatever, and then drill it, and then tap it.
Man, this little card's pretty handy.
Super handy. Okay, now find 3/8/16 and tell me what's the tap drill for it.
5/16.
5/16. Find a 1/4 and tell me what's the tap size for it.
13/64.
13/64 would be a little bit bigger. It's the closest fraction to it, though.
3/16.
Well, so a number 7 drill
Yeah, number 7 is perfect for it.
would be perfect for it, but a 13/64 would be really close to it. Okay. Last one. Tell me what we're going to do a 7/8 9. So 7/8 9 threads per inch. Tell me what's the tap drill for it.
7/8 9.
Yep.
49/64.
49/64. Okay. This also does metrics. This also does pipe threads. Okay. So tons of information on this little card. These little things are really vital to have with you.
Put one
These should be in.
wallet size.
Well, there's already a chart like this in the book.
Yeah, but this
So
is so easy.
these should be in your pocket.
These things need to be wallet
I'm
size.
saying to go to.
They're pocket size, dude.
That's why they need to be going to the testing center in the book.
So here's the deal on that. When you go to the testing center, you can, no, let me back up. You cannot bring notes with you. Now, I will say this, they do not check what's in your book. Okay, so if you've,
If that only forgets to be in my book, can be.
so I don't know that I would say that is a good thing to have in your book, because I think it's pretty visible. If you have Post-it notes in your book, because I don't want you to write in these books because they're mine, but like maybe you've written some details that you just need to have, like some notes, and you want to keep those in your book, but you can remove those Post-its when you leave. Those have seemed like they've been okay. So like if you put Post-its in there, like on the first page of the book that says, all my threading information is on 1871. My decimal equivalent chart is on this page. Those things are probably okay. I'm not saying that they are or aren't, but I'm just saying they seem to be things that are okay with them. I've never had anybody come back and go, hey man, they kicked me out because I had a Post-it in there. I probably wouldn't have them hanging out of the book. You know, I would not go down there
The bookmarks I have in here,
like that. I would not have them like that.
I don't even know who had them in there, but.
I would not take it down there like that. I would have those marks inside the book, so, you know, so it's less obvious, okay?
That's just our symbols and stuff for some of these.
Yeah. Okay, so a question that was brought up earlier, and I'll just give you this one, and then we're gonna do a couple of quick just micrometer checks, and then I'll give you your assignment, and then we'll move on, because we've already been in here for like an hour and some change. So, I want you to find gauge blocks in your handbook. And the question was asked by John earlier, or somebody said something about gauge blocks, and I just was trying to explain to you about gauge blocks in there. So find gauge blocks in your book. In the back, there is a huge index. You can just, rather than looking at the tabs, you can just go straight to gauge blocks.
Golly, man.
So much information.
It's just,
But it's about being able to locate that information quickly.
where's my G's at, man?
It's page 695.
Man, I feel like I don't even know my alphabet. Can't find G. C. Yeah, G, come on. There's E.
95.
F, G. Gauges.
Gauge blocks is the first one, bro.
695, 698.
Is there a pretest for the NIMS?
There is a pretest for it. And now it's just like a paper test, so like it's a PDF, so you can look in there and see, you know, like I would print it out, or either maybe just take a piece of notebook paper and write the answers down on it. Then you can go to the answers. I will say this, if you don't get 80% or better on the test, then you need to go back to the book and do some searching. In the book, there is an entire section, and this is the section that you guys have been working in. Okay, it's from section 2 on. It's literally called Measurement Materials and Safety. So what you guys have been doing in assignments are the assignments for this test. So when you've been looking at precision measurement, semi-precision measurement, different things like that, those are the standards that we're looking at. So I'll probably bring you back in on another day to do some other things too before we go and take that test. But
And that is next week.
it's next week, yeah.
What
So
day next week? All week?
I think it's one particular day.
I was going to say, I was like, that would suck.
We got two.
You get an hour and a half to do it. Let me find I'm sorry.
I might
Two
need them.
quizzes and the study guide left for this week.
Are you talking about for the assignments for this week?
We have two quizzes and the study guide, right?
I'll probably be in here for the quarter ends, whatever this is. Semester thing. Then we go to what class? It goes to machining 102.
101, 102, 103,
Don't I? And then metrology's a year class
It's a semester class.
or whatever. Yeah. What the? Man, I get so confused with all this stuff going on. And I look like Rudolph the Red-Nosed Reindeer because of it.
Okay.
Too bad.
Look, today is the 20.
She ain't that far behind me, and you're in the same boat. Actually, I'm actually surprised how much I got done on those handles. I almost got all the handles done.
I gotta pee really bad.
Yeah, just go down there. There's a couple of bathrooms down there.
All right.
You guys shouldn't use that bathroom. You pee all over the floor.
Not me.
Yeah, that's what everybody says. But literally, we've been like, hey, let's stop having students use that. Every time you come out of there, it's just like, it's like somebody just went up the walls and stuff, and you're like, what happened? So, all right, let's talk gauge blocks. We'll talk about our NIMS test. All right, so if you look at gauge blocks on 695, this is what I'm talking about, how it doesn't necessarily say there is a certain amount of gauge blocks per set, okay? So like if you look at, flip over 697. Here's a gauge block set. 697, about halfway down, it says set number 1, 81 blocks. it says in the first series, 0.0001 to inch, or 0.0001, so 1/10 inch increments, there are 9 blocks. From 100 thousandths and 1/10 to 100 thousandths and 9/10. Second series, 1,000ths increments, 49 blocks. Okay, so what it's saying is, yes, there's 81 blocks, but it's saying within there are 10 blocks that stagger this size. There are 5 blocks that stagger this size. So like the question on a test might be, how many gauge blocks are in a standard gauge block set? 81. How many blocks in that set go in 10th increments? Well, you won't have a gauge block set in front of you. So you're going to have to look here and see how they move in 1/10 increments. There's 9 blocks, there's 4 blocks, there's 20 blocks. Those are the things that you're going to have to look for, okay? So information, location like that. Those are going to be things that are really important for you to see.
When it comes to the test, is it all going to be multiple choice?
It is all multiple choice.
But there's going to be ones where you have to read a mic and stuff like that. Are we going to have to read certain things like dial calipers and mics and all that good stuff?
Yep.
Are we going to have a day or like, can I spend time reading micrometers or something? Because
Sure. You should have already covered that in metrology.
I did, but
So go ahead and do this. Let's just do that real quick. Go ahead and grab a 0 to 1 micrometer and let's take some measurements on your handle. So everybody go grab your 0 to 1 micrometer. I'll go grab one myself.
measured ones too, or
No.
they're not going to make
I don't think that one covered metric enough.
Well, I covered metric ones in metrology. Yeah, I had to get my hair cut because the other day, when I went to my family event, before the family event, I was in the kitchen and I went like this with my hair, like right after I came in, and there was a piece of bronze came out. I was like, so he's gonna cut my hair. There's all sorts of metal shavings getting in there because it's too long.
Does happen. Okay, first thing I want you to do is I want you to measure, you had asked the question of how thin this paper is. You should measure the thickness of a piece of paper, of the machinery handbook piece of paper.
Okay.
Measure the thickness of the machinery handbook piece of paper. The machinery handbook piece of paper.
Oh, I'm just trying to clean it.
Okay, that's fine. My micrometer is janky. It's got some junk in it. I always end up with the junker ones.
I could just. It won't slide out. There it goes. I got 0.
200 thousandths? 200 thousandths would be about 3/16 of an inch, just a little bit shorter than a quarter inch.
I can barely see through the micrometer now that I got the paper pulled out. Where's the vernier scale? Come on, man.
So just don't even use the vernier scale, just measure it to the thousandths, it'll be fine.
I got 2,000.
I did too. Yep, when I checked mine, I got about 2 thousandths. So if yours is not zeroed out, you know how to zero it out?
Is this the tool?
Yep. If it needs to be zeroed out, go ahead and zero it out. Make sure that it's calibrated. Even as yours go down to 0. Okay. So, looks like you're missing the whole calibration tool. And as soon as he's done, we'll grab his or Hunter's caliper. So this barrel on here is really not attached to anything. So you just roll it up here to 0.
Okay.
So then, maybe just a little bit more.
I got my thing calibrated. I did 2 pieces of this, but I didn't know I was doing 2 pieces. That's why mine wasn't reading right.
That's way better.
Got about 2 thou.
A little under 200, but yeah.
200?
Thou.
200 thousandths.
A little under, but yeah.
Just shortly under a quarter of an inch.
No. Not a quarter of an inch.
Then it wouldn't be 200.
2 thou.
There you go.
Okay, so does that paper feel thinner than a normal piece of paper?
Yes.
How thick do you think a normal piece of paper is?
I probably think 4.
3 thousandths. So, but I mean, if you think about it ratio-wise, it's only 2/3 the thickness of a normal piece of paper. So, like ratio-wise, if it was an inch, it would only be 700 and some thousandths of an inch, right? So, like ratio-wise, it's a pretty substantial amount of material. So, like a solo cup only has about a 3 thousandths edge around it to the wall thickness of like a regular.
Construction paper might be 5.
Probably 5 or 6, yeah, I mean, it's thicker, yeah, so absolutely. So, okay, go ahead and measure the diameter of your hammer handle at this point back here. Okay, so just take your micrometer, it should be around the 500 thousandths area, it's gonna be a little under.
Which part?
The part that the threads go on, it's be behind the threads.
Right behind the threads. So was I supposed to make mine taller by else everybody?
I had said, let it go a little bit past 1/2 inch. You're fine. You went a little far. That's okay.
It just looks cooler. Jeez.
Mm-hmm. Yeah, you can definitely think that.
Yeah, I think it looks cool.
Yeah, I'm glad.
I was showing this thing off to all my family members. I was sending them pictures, showed them.
Cool.
Slide off. It's too tight.
You got
4, 475.
So you got 400 Then you can read, the next ones are in increments of 25,000, so if you see 3 of those, you're at 475.
475, and
Then around that is 25,000. So you're counting out from 475 up another 25, or no more than 25 to get to your next.
So 475, then you add?
And you add the last increments that you get up there, so it might be at like 20.
Plus 475.
So what does yours say, Stephen?
475, and then there's 17, so just under.
Okay, so it's 425, or I'm sorry, 475 plus the 17. So what's that?
487 is what I got.
487?
487, but I haven't done the vernier scale yet.
Mine's over 5.
Over 5.
Yeah.
487.
I think it might be the micrometer out.
487.
487.7. Okay.
I mean, all of ours are going to vary. None of them are going to be the same. There's no
While you're checking them, yeah.
unless we did like CNC, they might be close. They'll be closer.
You should be pretty close.
When you're manual doing stuff.
But you can make, manually, you can
almost.
definitely make parts that are as good as the CNC. I don't think that that's an
Not as
issue.
efficient.
Probably not as efficiently, but what I think more than anything, it's just really the variation of you learning how to do this stuff. You know, that's what you're.
I love that.
Yeah, go for it.
I love that I know how to run a lathe and stuff like that. I think it's so cool. My uncle actually, he's getting ready to start a business where he's building guns. He has his license for like I can't remember what it's called, an arson. But he asked me if I wanted to come down there and help him or something like that, and show him, because he has a lathe, but he only has one that he can do. Right now, he has like a wood one, and you could do maybe bronze, like softer metals on it. But he's getting ready to get he has a one, but he wants to get it, the voltage and stuff figured out on it.
Dental hygiene clinic here is trying to call me.
Where did Eric go? He went to the restroom, didn't he?
Okay, so now I want you to measure the next diameter on there, which should be 750.
You said the outside one?
745.
Yeah, that's fine. I'm not concerned about what it is. I just want to know what the diameter is.
Oh, he ain't gonna get too big on some things.
Holy shit.
Mine's way over.
Mine's a little bit over.
Mine's about 25,000 off. 25,000.
What is it supposed to be?
7.
7 even.
Fucking, yeah. Let's say here's 7 even, holy shit.
No. Is it supposed to be? I thought he said 7.5.
Yeah, I thought he said
What is it supposed to be?
750.
You scared the shit out of me.
I thought it was
Not 7.
I thought it was 7.
I was like, I got more to take off. No, I'm just like.
You are just right at, yes,
Right at.
almost 751. I want this micrometer for a second.
Good.
It's missing a screw,
Oh.
and so I just went and took the screw out of mine. I don't want you to lose this handle.
7.
Arrow.
Come on. Alright, that's like perfect.
747 is what I got.
747, that's great.
I'm at like 751.
Yep. Totally good.
I'm at 7,
750 and then probably a 9.
745.
745, yep.
745.
That's failure. What?
What? Whatever, it's 5 blood, really?
Okay, one last thing. Does everybody have a scale with them? No? Measure the thickness of your pitch gauge then. So take one of those blades, measure the thickness of whatever your 13 out or whatever blade that you have out. Let's just see how thick those are.
He said get the 13 out.
Yeah, it doesn't matter. They should all be about the same. Oh, my gosh.
This is one Eric should be doing right here. I can't imagine trying to figure this out for the first time while doing a test. That would suck. Because when he was in here teaching, when Ed was teaching me this, I was still like, I mean, I get why we use micrometers, but they are definitely confusing at first.
So pretty soon we shift over away from the calipers and more towards micrometers.
I like calipers though; those are cool.
But they're just not as accurate.
Yeah, that is true.
So we kind of do, you know, I like to use the example of Lego steps. So we start with the Duplo blocks, then we move up to the Lego blocks, and then we move up to the Lego robotics blocks, and then we move up to making the Death Star and stuff like that, you know, so we're,
Making stuff out of just random blocks.
yeah,
I
so.
got about
20,000.
That's what I got.
21,000.
Yeah. Okay. I may pull you back in towards the end of the week just to catch up. Like I may grab you on Thursday. We need to talk about some heat treat, some other things like that, that are going to be on that test. And we've talked about metal classifications already. We talked about that last week, I think. 4140, 1018, stuff like that.
Plain metal or whatever.
Metal, yep. Mild steel. Yep.
$10,000 tool.
Yep, absolutely. So let me give
Any
you,
updates on the scholarships?
all I know is that they have, all of my stuff has been sent out. So I would say for you, you need to be checking your email, because I think you'll see something in your email or in my SFCC, like where you should see something like a congratulations.
Did you see my scholarship application?
I might be able to see yours. Let's see.
Because
Let's do this. I'm going to let you guys, let me talk about this and then we'll go back and look at yours.
I need some.
Module 6 is where we are. Okay, so I want you to go ahead and do the thread info quiz. I want you to, because it talks about taps, it talks about OD threading, machinery handbook and micrometer quiz. You'll want to do that here because you'll need a machinery handbook and a micrometer. And then this one is kind of a do on your own. There's no scoring for it, so.
I'm just gonna do in-class stuff today then, since I got all these.
Fine. Don't forget though, every time that you take time out of doing that, like you're losing time. Don't forget, like as it stands right now, your current grade is your current grade. Right, so if your grade is looking like 40%, then you're like, if the world blows up tomorrow, then that is your current grade. Okay? So now, obviously, we're almost done with the project that is a 190-point project. That will greatly change it. But what I don't want to do is I don't want, students are eternal optimists on grades and time. They don't seem to quite know how time works. Like I will have a student in an 8-week class who has not completed an entire project, wait till week 7, and I'll be like, you need to drop. And they'll be like, no, I think I can get it done. And I'm like, there's no way you're getting it done. Like there's just no way you're gonna do it. And they're like, no, I'm pretty sure I can. And then when they can't, they're really surprised. So I want you to make sure that you pay attention to time management. In the place that we're at, you guys are totally fine.
Everybody, including me?
Everybody but you. So yeah, no, you're fine. Your projects are doing fine. I just want you to see, I just don't want to candy coat any kind of grades, you know, so I don't want you to be like, oh, don't worry about it. Everybody will be good.
Well, I checked them like right Friday, and I was like, oh, I'm doing okay.
79, I'm good, you know, so.
I came in today, I was like, oh, yeah.
So I just went through and did that this morning because I was like, I think we got a couple people who aren't, well, and here's what happened is I went out and told the other guys that in the same thing that I just told you guys. And one of them's like, oh, I got 4 projects in my box. I'm like, but I need those projects. I can't grade them unless they're in my hands. And they're like, okay.
That aluminum piece hand tapping that. I've been trying.
It's fine.
That's about it on that
No
piece.
big deal. And we'll get that turned in, get it graded, and get your grade back up to where it needs to be. So yeah, just don't want things lingering. And I don't want you calling me on the 17th at night. You go and, hey, I know it's 9 o'clock, but I promise you, I've got these projects done. I'll take a picture of them. can I get a 287% on this? Because it'll save me. And I'll be like, no.
What if it's 1 point percentage though?
So-
Would you save us?
So here's what I do is I try to not round either way. Because it can be really detrimental. And so if it's a 91%, it's a 91%. If it's an 89%, it's an 89%. You know, my thoughts are, if you want to make sure you get an A, it shouldn't be so close to 90% that like you are really fighting me for a single point to get to from 89 to 90. Like you should be.
I care less about getting an A. I care about getting that B or high C. Like I want to pass decently. Like obviously I'm doing my stuff.
Yeah.
I want an A.
Yeah, just make sure that you're kind of buffering yourself in there so that you're not really at that tipping point of 90%. Like, I don't want to have to do that. I don't want you to have to do that. So if you're shooting for an A, like shoot for 92 or higher. That way you've got some buffer room in there. So really with 101s, there's really no reason that you should not be in the A's and B's. You really shouldn't start seeing, like, honestly, second 8 weeks, the second 8 weeks of your first semester is almost one of your hardest semesters. So we start into intro to CNC programming and some of those things, and so that becomes much harder. So,
I'll figure it out. I finished up early. Would you mind showing me some CNC? Because I won't be here for the.
yeah, as much as I can. I'll try to have one of them going today, and we'll do some thread milling, just so you can see how thread milling works. And as long as I've got stuff going on, no big deal. Right now, we just don't have a ton of free time to walk through a ton of that stuff. But yeah, I know where you are.
There's so much stuff going on with this new building and all this crazy stuff going on.
Yeah.
I mean, I don't have to deal with it, but you guys do.
Yeah, like the thing for the governor this Wednesday is,
And why is the governor wanting to come up here?
he wants to come here because the state paid for a lot of this building, so they paid for half of this building.
Wow.
And then some of the contents of it as well. So this is a investment of the community, and really the community should be able to come in and see it all the time. So
I like it.